Good morning, students. Already I explained about the RFID. In this session, we are going to discuss about the RFID introduction. I explained about the RFID frequency ranges, which means frequency ranges. I explained. So low frequency, high frequency, and ultra high frequencies. In previous session, we have seen. Somewhat we will discuss about the introduction of RFID. What are that? Radio frequency identification, the technology that uses radio frequency waves to transfer data between a reader and a movable item to identify or track or categorize the objects. RFID is fast, reliable, and does not require physical sight or contact between reader or scanner and the tagged them. See, I told no the chip. The chip is inserted into this chip is nothing but RFID. It is made by copper material. Okay. So I told the components of the RFID. So what are that? RFID tag, RFID antenna, RFID reader, and RFID station is nothing but computer which collects the database from the tag and the reader. This is the RFID technology. What are the components are there in RFID technology? This is tag, this is reader. These are nothing but the waves produced by the reader. At the same time, the object also observe the energy from the reader. How it will reflect and observe the energy by using antenna. So the antenna is connected. It's not connected. The antenna is in between tag and the reader. Depends on the frequency ranges. It observes the waves from the reader to tag. See, this is the RFID station, which is nothing but computer. These are the different types of tags. The reader sends the radio waves to the tags. At the same time, the tags observes the radio waves for the particular frequency range, and it sends it gives the feedback like that. So it sends the energy to the reader. So the reader reads the full information from the objects, and it transfer to the computer station by the antenna. So, what is RFID technology? Radio frequency identification. Some microchip is labeled, used to transmit data when the label is exposed to radio waves. These things are I explained in first session. So here the tags are made of these parts. What are the chips? Hold information about the physical object, antenna, transmit radio signal, package, encases the chips and antenna so the tag can be attached to the physical object. See here, this is the antenna, small antenna. This is the small antenna. This is the chip. And this is the full package. It's like protection purpose. RFID basis, active and passive. Passive have no any power supply. Active, it have own power supply, which means the battery is connected into the device. Active tags. It contains a battery that runs the microchip circuitry. Tag is able to send a stronger signal to the reader due to battery. Allows a read range of about 100 feet. The distance between the object tracks the object. Okay. Passive tags. Passive tags contains no batteries. Passive tags get power from a reader. Readers send electromagnetic waves that produce a current in tags antenna, which then powers the microchip circuits. A passive tag's read range is approximately 30 feet. So it depends on the frequency range. So what is the depends on the frequency range means if we are using low frequency, it comes at a megahertz. Depends on that megahertz, we use the distance between the reader and the object. 10 centimeter for low frequency and higher frequency for 1 meter. 1 meter. The distance is occurred in 1 meter. And ultra high frequency, the distance is 10 to 15 meter. If we use more range of frequency operations, in that we can use the higher applications like military. So this kind of higher applications we can use if we use ultra high frequency, which means comes under microwave frequencies. It's nothing but a gigahertz. This is the operating principle of RFID. So, two types of working principle is there. One is inductive coupling. Second one is inductive coupling. Second one is um, electromagnetic coupling. Inductive coupling means it used for only near field coupling. The distance is very less between tag and the reader. But electromagnetic coupling, we can use the ultra high frequency RFID tags. So the distance between the tag and the reader is nothing but a far field. Far field coupling. The coupling between the reader and the tag is very far. So here the intensity load we can connect. The load is used for on and operation purpose. I will explain in this diagram. Okay. So first we will explain about what is inductive coupling. Inductive coupling is nothing but induce enough power supply into the tags. Second point is synchronization clock to the tag, and it acts as a carrier for written data from the tag. At the same time, it's very close to reader and tag. It's very close to each other. The coupling is mutual coupling in inductive coupling, RFID tags. This is the RFID reader. This one is the RFID tag. So this is the coupling, which means the reader have one couple and this tag have some coils. These are the coils. Due to this coils, the field will be coupled between reader and the tag. So what coupling? Inductive coupling will generate from the reader and the tags. So here we use the loads. Depends on the load and the rectifier circuit. The load, if the load is an on condition, the power supply will move to the rectifier. So here one diode is connected. This rectifier have the half wave rectifier, full wave rectifier when the switch is in on condition or off condition. If we have energy, that energy will store in this capacitor. After this energy will move to the this chip, this organizer. This code. Again, it will give the feedback to the reader. This reader gets the store the energy and it reads full detail of the tag. So this type is nothing but inductive coupling. If I'm going to use the electromagnetic coupling, the electromagnetic waves will produce the coupling here. The coils are coupled electromagnetic waves. So that electromagnetic coupling we can use for far field RFID tags. So already I explained RFID systems consist tags reading devices that convey information from the tags to the computer, and an unpowered tag is powered intermediately from a distance by a reader device that broadcasts energy to it. Tags consists of plain antenna bounded to a silicon chip, and I told that material is made upon copper material or silicon chip material and encapsulated inside a glass or plastic module or any chip, any papers, any layer of papers. So what are the applications of RFID? In real time, we can use in malls, books in library, medicals. The records are maintaining in medical, particular patients' health care. People tracking, hospitals and jails are most general tracking required places. Hospitals uses RFID. That thing only, the patient's healthcare fully give the total amount of the information from starting onwards. When he joined, when he, what happened, the total history of the patient's healthcare. In medical purpose, we can use and manufacturing. So, which is nothing but purchasing, manage a huge and labors manufacturing process. These are the some of the applications of RFID. So what are the advantages and disadvantages? Yes, these are very, very important thing. We know we should know main thing is disadvantages of RFID because we are human. So easily it will affect due to the electromagnetic waves. So we should know what are the disadvantages in RFID. Before that, we should know the advantages of RFID. RFID tags are very simple to install or inject inside the body of animals, thus helping to keep a track on them. The RFID tags can store data up to 2 kilobyte. RFID technology cannot be easily replicated and therefore it increases the security of the product. Disadvantages. It is difficult for an RFID reader to read the information in case of RFID tags installed in liquids and metal products. RFID technology has been referred to as invasive technology. Many countries have different range of frequencies that allow RFID tags to function. So these, and it's very privacy also. So this slide is a simple thing for RFID versus barcode. Before that, we want to know about what is barcode. I will explain next session about the barcodes. So simply we can say RFID versus barcode. Barcode is comes under line of sight technology. RFID is more effective. Barcodes have limited information only. So because it's using line of sight technology. Okay. So in this session, what are the things we have seen? RFID introduction. First class also I explained about the RFID introduction, basics, principles. So introduction of RFID components, working principle. This is basic working principle only. Okay, and this is RFID technology. Chip, how the antenna and chips are holded in the tags. Basic types of RFID, active, passive, operating principles of RFID, which means two coupling modes are there. The principle comes in the two coupling modes. One is inductive coupling. Inductive coupling, low and high frequencies we can use. For second thing is electromagnetic coupling. It comes under ultra high frequency RFID tags. This is working principle, and we know the real-time applications of RFID. And advantages and disadvantages of RFID. This is nothing but RFID versus barcodes. So before that, we should know about barcodes. Then we can compare the RFID and barcodes. Okay. If you have any doubts, you can ask me through messages and whatever it is. Thank you, students.